In the last class, we were discussing about the differences between database and data warehouse, right? We have started with the
Yes, sir.
definition. We have started with the why we have to go for the data mining, right? And the basic things we have discussed in the last class. Then there comes the data warehouse, and in the data warehouse, as I have told you, that we keep data in a summary form, and that summary form should be time oriented also. Means we keep the historical data means what, like say last year data, then say 2024 data. In that way we keep the record. And the question is that
Okay.
why we are keeping the historical data, because whenever we analyze our old record, then only we can find out that in what part we are lagging behind and in which way we can increase the profit, right? Ultimately, we have
Yes,
to increase our profit, and this there actually requires the decision making. So basically, this process is required for decision making, right? Then last again we have found that this data warehouse, these are the characteristics, but you also know that in database also we have kept the data. Then obviously there exists a question in our mind that what is the difference between database and data warehouse. Now, in this table, you can see clearly from first point we'll discuss. The first one is in the case of database, it is transaction oriented. This means to say transaction means what? Say, we have inserted some data. That is a kind of transaction, right? We have
yes,
deleted the data. That is a transactions. Like in our case, if we go to the ATM, and if we withdraw some money, what will happen? The balance of the saving account will be debited. Yes or no?
sir.
So that itself is a transaction. Okay. So when transaction
Mm.
happens, some kind of data is generated or deleted, whatever it is, it gets stored in the database. So database takes into the picture when there is some kind of transaction happening. So that's why I am
Yes,
writing here database is transaction oriented. But in the case of data warehouse, what is happening? It is subject oriented. Now, subject oriented means what? That there are different in a company. If I consider one particular IT company, there will be different verticals. Say one vertical is HR, another vertical is say sales, another vertical is say marketing, right? Another vertical is say technical. So there are different verticals. Now, that vertical wise data will be different. IT people will deal with the IT related tasks. HR people will do with those HR related tasks. Similarly, our say marketing people will more concerned about the marketing data, right? So now what happens that if we divide this data in these different disciplines, or you can say subjects, different disciplines or subjects, then it will be more clear, or it will be easier for us to analyze the data. Are you agree with that?
yes, sir.
Right, because you see,
Yes, sir.
yes, good. So because see, if a technical person will be provided with the ASR data, he will be confused. He is more related to the coding kind of things, error kind of things, but he has no idea how to tackle the ASR task. So this is the principle applied to the data warehouse. We separate the data as per the different subjects, in both terms subjects, right? Different subjects. Like in our case now, in this example, HR will be one, IT sector will be one,
Yes.
marketing will be one. So accordingly, those different subjects, we put the data. So that's why we use the term the data warehouse is subject oriented, not just like transaction oriented. Transaction होगा ही what happened at transaction, it is okay, transaction होगा तो इसलिए data generate होगा या तो data delete होगा, ये database का काम है. But in the case of data warehouse, it is subject oriented. It is not just only the transaction, because transaction is happening in the real time and real-time generating data. But in the case of data warehouse, we are more concerned about the historical data than current data. Yep, this point, please, you can note it down.
Yes,
Now,
sir.
next difference is that, like database for saving online bargain data. Second, in the case of data warehouse, for saving the historical data. Just I told you that if we go for real-time data analysis, then more what database is concerned. But whenever it is historical, matlab last year or then again 2024, then this type of historical data we deal with data warehouse. Next, if you can recall, then you know about ER modeling. ER means what? Entity
Yes, sir.
relationship modeling. Very good.
And it
Entity relationship modeling. So these entity relationship modeling techniques are used for designing a database. Okay. But in the case of data warehouse, we are not concerned about ER modeling. We are more concerned about data modeling techniques. Okay. We concerned about the data modeling techniques for designing. We will go through such data modeling techniques. Now, next difference is that in database, we capture data. Means we put the data, we store the data. That is our main part, right? But in the case of data warehouse, what is our main aim? Main aim is to analyze the data. Main aim is to analyze the data in such a way that we can perform some decision-making process. ठीक है? Are you getting my point? बुझी पाइसा?
Yes, sir. Yes, sir. बुझे पाइছে, sir.
Okay. Now, next difference is that database constitute real-time information, while our data warehouse constitute entire information base for all time, because we put all the data in a summary, not as it is, but in a summarized form in a data warehouse. Well, these are the differences between database and data warehouse. I hope you have noted down. Now let's come to the next point of discussion, that is OLTP and OLAP. OLTP stands for Online Transaction Processing. OLAP stands for Online Analytical Processing. Both of these techniques are related to the data processing, right? Data, how we process the data, that actually brings these two techniques, OLTP and OLAP. Now, in case of OLTP, the major task is to perform online transaction and query processing. It is like we use day-to-day operations in an organization, while OLAP, it is serving the knowledge workers, means us, like us users, in the role of data analysis and decision making, and it organizes and present the data in various formats to accommodate the diverse needs of the different users. So what is the thing different? So in one case, what we are doing, we use for query processing. Query processing means, suppose there is a query, say I want to know the roll number of Himatri. Okay, so I will search this ID, select ID. where first name is equal to Himatri. Yes, this is a kind of query, right? So for this type of online transaction and query processing, we use online transaction processing, that is OLTP. It is a kind of day-to-day operation. But OLAP is a kind you can consider as a one step above it. It is used for analytical purpose. Analytic mane ki? Analytics ka matlab ye hai, we have to carefully observe the data. We have to find out the pattern. We have to perform some decisions making. Are you getting my point? So this OLAP presents the data in different formats so that you will understand about the insights of the data. Okay, then accordingly you can find out that, like, yes, in our, suppose in your company there are more females than males. That is a kind of observation, that is a kind of analysis. So to know that, you have to know insights of the data, and if to know the insights of data, you should have a graphical representation of data in front of you so that you can better understand that yes, male is numbered like this and female is numbered like this. Similarly, from them, suppose you want to find out those persons whose last name is, say, Sharma. Again, this is a kind of analysis. So for this, we go for OLAP, and just for day-to-day tasks, we go for OLTP. But both of these techniques fall under what? Data processing techniques. Now, if you compare these two in minute wise, you can find this table useful for you, like OLTP and OLAP. So OLTP day to day में काम में हो रहा है. Day to day means what? Anyone can do that task. So users will be normally clerks, IT professionals. They are the users for the OLTP. But अब जब analyze की बात आती है now, then what happens? We obviously refer to a person whom should be a kind of knowledge worker who has the capacity for analysis, right? So OLAP is for knowledge worker. Okay? Similarly, function. OLTP, I told you that this is a kind of query processing only, so it is a day-to-day operation, right? But in case of OLAP, we do that only for some decision-making purpose. So this is a decision support, right? And DB design, database design, is like OLTP. TP. It is application-oriented. Obviously, application-oriented. What type of applications you are using and for what purpose you are using. But in case of OLAP, again, it is, I told you, it is a kind of one step above. So here we will more focus on one domain or one subject. So this is subject oriented at a time. Then data means what will be the input. Here, current up-to-date detail, right? Flat, relational, isolated, this type of data we deal with OLTP. But OLAP, we use historical data, we use summarize, we use multidimensional, integrated, consolidated, this type of data we use in the case of OLAP. Now, in the case of uses, it is a repetitive task in the case of OLTP. OLTP बार-बार एक ही query आप perform करना पड़ सकता है. But in the case of OLAP, it is not mandatory that every day you have to perform the same tasks. It's a kind of ad hoc. It is not. Whenever we need to perform some decision, need to perform decision making, then we go for it. Access. It's like, read, write, dozens of records. But in the case of OLAP, as we are performing decisions, we have to concern more data, so millions of record read. Unit of work, OLTP, short, simple transaction. But in the case of OLAP, obviously, it's a bit more complex query. Records access. So how many records may be needed at a time for a user purpose, for a, say, IT professional or clerk? He needs only tens like that amount of records. But in the case of OLAP, as we are performing some crucial operations, we have to rely on more numbers of data, that is millions. Users may be thousands in the case of OLTP, because see, so many users may be available. Like, IRCTC website, everyone is booking the ticket. Yes or no? Train ticket, everyone is booking. So users may be more, maybe not, maybe it is used, it confirms that in the case of OLTP, users number will be more, right? They are just performing some transaction, simple transaction. But OLAP, what happens? From that transaction, you try to find out that, yes, in the road, Guwahati to say New Delhi, how many trains being booked during the evening period? That's a kind of decision making. So that can be done by only some knowledge workers. So there will be very few of them. So hundreds. So if number of users in the case of OLTP say thousands, it will be very less in the case of OLAP. Okay. Yeah. Then size will be, say, user. In the case of users, it is less every user. But in case of OLAP, we are more focused on the maximum numbers of data, right? We have to keep in a larger space. So that is more than OLTP requirements, and more likely like 100 GB to TB. Okay. So these are the differences between OLTP and OLAP. Is it clear?
Yes, sir. Clear, sir.
Okay, good. Now, if you look at this picture, it is more clear to you, right? OLTP systems are used to run a business, right? Because users are using. But to optimize to optimize the business means what? We are maximizing the profit. What we need? We need OLAP. And OLAP is nothing but what? We are performing it in a warehouse. Right. So data warehouse helps to optimize the business. So business को चलाने के लिए OLTP is sufficient, but business का profit making को ज़्यादा करने के लिए, optimize करने के लिए हमाक লাগিব data warehouse, right? Because there we perform our OLAP operations.
The data warehouse to OLAP ভিতৰত পৰিব নেকি?
No, that's right. Data warehouse is a storage space. This data warehouse is a storage place. But কেনেকুৱা storage place? It is the storage place where we keep the summarized data, where we keep the historical data. Now, data থাকিলে নহব, data ওপৰত কামো কৰিব লাগিব. So to perform those tasks, because only the data is not going to help, we have to perform some analysis, right? And to perform that analysis, we are going to need what? OLAP. Is it clear now?
Yes, sir.
So warehouse is a kind of what? It is a kind of storage, but just 1 minute, huh? Yes, the question.
5 minutes away.
Huh?
5 minutes away.
5 minutes.
Just 5 minutes.
Just 1 minute, huh?
2 minutes away.
Okay, sir. Yes, sir.
Yeah, sorry. Then now, if we see architecture of a data warehouse, right? Architecture means, in the case of database also, I told you about 3-layer architecture in DBMS class, right? So similarly,
Yes,
in the case of data warehouse also, we have a kind of typical architecture. So if you can take a screenshot and you can see here, first it is data sources, means from where we are getting the data. Okay. Now, there we perform, after that we perform ETL. ETL stands for extract, transform, and load. I'm repeating, ETL, very important term, kindly note it down. ETL stands for extract, transform, and load. So after doing these ETL operations, we keep the data, summarized data in the warehouse. Right. Now, from the warehouse, what will happen? With the help of some models, we actually access the data, we analyze it, and we present it in different forms like dashboard, prompted views, right? Scorecards, some report, ad hoc report, or some kind of self-serve. So this is a typical data warehouse architecture. First data source, then we perform ETL there. We keep the data in the data warehouse, summarize data, then we keep some models who will analyze those data and present it in some particular format. Formats are there, right? Now, in case of data warehouse and more formally the data mining also, we always try to focus on multi-dimensional data model, right? Multi-dimensional means what? We take more than one attribute at a time. More than one attribute means you know about attributes like, in the case of
Yes.
DBMS, we have columns, right? Similarly, here we
Yes, sir.
call it as a dimension. If we take
Mm-hmm.
multiple dimensions, then it will help us in the analysis process. So it is a usual process that we consider multidimensional data model. So these models are developed for implementing data warehouse and then again data march. Data march is a kind of short form, you can say, we'll discuss. Then it provides a mechanism to store data and a way for analysis, right? And you can consider it as a kind of alternative to ER model. Like ER model, what we saw the relationship among different entities, right? That is the main purpose. Here, we saw the relationship among those different data for different dimensions. And there are different models like, data cube model, then some schemas, star schema, snowflake schema, fact constellations or galaxy. So there are different schemas we use for multi-dimensional data analysis. Now, data cube is the very common one or frequent one we use. We consider it as a multi-dimensional data model which views the data in the form of some cubes. Cubes we know, right? And some concepts are associated like slicing, dicing, and rotations. Right. These are some operations, slicing, dicing, and rotation. And we perform in the cube to find out that particular data we are interested on. Like in this example, you can see this is a cube. And here, what you can see, some geography, right? The information, some age group information, and what is other? They are ethnic origin. So we consider more than two attributes. Are you getting my point? So every cube, if we consider, these three are associated. Means in one cube, we find that geography means which location, right? In that cube also, we can find out the age group, right? Say it is 25 to 34. Say it is 18 to 24. So similarly, we can find out the ethnic origin information also, that he is British or he is Indian or he is German, like that. So this is an example that we can easily find in a data mining book. And this is 1991 Canadian census. Now, slicing operations. Slicing means I just told you that we just take one cube and we find out that what is there. Like here, uh, in this case, just 1 minute. If we consider, if you can see my mouse cursor, say I am pointing towards, let me take this one. This is more clear. So if I am considering this one is say This is Alvaria. Okay. And then this is, say, if I'm considering the first one, then this will be fall under 55 to 64. And this will again, the origin, ethnic origin, if we are considering, this is Portuguese. So slicing means
Portuguese.
we use just pick up one cube, and in that cube, as per the dimensions concerns, you get different information. Like this cube I'm talking about, suppose I am considering this one, and there also you will get some information, different informations. So that is a slicing process. The data that is contained within the cube has effectively been filtered in order to display the measures associated only with the Chinese ethnic, means in here they are taking Chinese ethnic origin. So that's right. So from an end user perspective, the term slice most often refers to a two-dimensional place selected from the cube. Then dicing is related to operations to slicing in which a subcube of the original space is defined. It provides the user with the smallest available slice of data, enabling you to examine each subcube in greater details. Right? Means if you take a cube, that is slicing, and inside that cube, if you can take only one dimension or the like subcube, then that subcube will give you more clear information with respect to particular dimension. So dicing is nothing but operations related to finding out subcube in a cube that you got it from slicing. Right? Then rotating, sometimes it is also called pivoting. The sense is the dimension of dimensional orientation of the report or page display from the cube. Means you rotate the dimension, accordingly you display the data as per your own choice. Rotating may consist of sweeping the rows and columns and moving one of the rows dimension into the column dimension. So if I talk in the very layman words, then rotating means you are just rotating the dimension. In the case of here, this is geography, this is age group. You consider here age group and this is geography. But similarly, dicing, again in layman words, what happened? Say you consider this cube, and in that cube, you are more interested on this geographical portion. So that is dicing. And slicing, you already got to picking up one particular cube from that particular data cube. Right? So these three operations we perform in the case of a data cube. And data cube is a very simple yet good example of multi-dimensional data model. Is it clear?
Yes, sir.
Okay, that's it for today. So I hope whatever we discussed today is clear now, right, Randy?
Yes, sir. Yes, sir. Sir, syllabus খন দিব পাৰিব নেকি? Data mining or?
syllabus already দিয়া হৈছে, তোমালোকক দিয়া নাই নেকি?